This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This March 21st and 22nd, don't miss Tech Ignite in Burlingame, California, just minutes from the San Francisco airport. Come to Tech Ignite to get rock-solid info and forecasts on adaptive cybersecurity, emerging technologies, machine learning and deep learning, operational intelligence, and much more. Join tech superstars Steve Wozniak and Grady Booch, plus C-level leaders from Netflix, Google, IBM, Salesforce, GE Digital, and Intel to gain valuable insights and learn about real-world solutions you can start applying today. Register now for the IEEE Computer Society's premier conference, Tech Ignite, at techignite.computer.org and discover the truth behind technology.
Hello everyone, I'm Felienne for Software Engineering Radio, and I'm here today with Alexander Tarlinder, who is a consultant at CRISP. He has a decade of experience in software development, but he's also worked in architecture, management and testing. And over the past few years, he's really been getting interested in test automation and continuous delivery. But the reason I'm interviewing him today is I just read his book, Developer Testing. Hi Alexander, welcome to the show.
Hi Felienne, thanks for having me.
So first of all, I want to know, why did you write this book? Because there are a lot of books about testing already. Why did you think there was a need for another book on testing?
Oh, well, that's a great question. Actually, I've seen many needs. So after a while, after having done certain consultancy thingies, I kept bumping into the same recurring pattern of problems, the same phenomena, the same learning curve. And I read a lot myself. I used to run a book review site. And so I was quite aware of the market, and I was aware of the literature back then, what questions it was addressing. And I really did see a gap. And the gap was basically that, at least to me, there were really two camps when it comes to written material. And one camp was the testing literature, which was very good at conveying information about testing techniques. But what happened in many of these books was that they tended to drift off in the direction of a testing process. And that is something I, as a developer back then, couldn't really relate to. So
it was focused too much on the tester and not on the developer. Do I understand that correctly?
Yes, the tester, and actually not really that. I wouldn't even go there. I'd say some of the books, not all of them, were actually focusing on just process, on how to document stuff. To me, it was very intangible. So that's one thing. And then we've got all these like developer books, and they're usually, the ones I read usually had like JUnit, XUnit or something in the title. And again, they sort of favor the tool. They were very good at explaining the tool. But what I saw missing was what to actually put into this tool. Okay, you've got this tool running, you know how to write your unit test or whatever kind of test you're writing, and okay, so what you're supposed to put into this test. And then there was another third camp of books, which was Tdd Books, and this was very interesting because, again, at least it was my opinion that books on test-driven development, they stopped after having explained test-driven development as a technique. Probably we're going to return to that topic sometime, but again, I was missing what to actually put in the tests. So that's one angle. Then the other angle is, as I said, I've been working as a consultant with different clients, meeting different people, seeing different organizations, and I've seen recurring patterns of sort of stages of quality awareness in teams, and these stages usually they usually involved developers knowing something about a unit testing framework. They knew something about a mock framework or something, and then there was this gap, and there was actually not, again, I saw that not too many people were concerned with what to put into their unit tests.
Yeah, so there needs to be a book that explains people what to test or what tests to write, and not really how to write the test and how to do the techniques of the test. I think that's how I can summarize your answer.
Well, there needs to be something. There needs to be some meat in the unit test, so to say, what to put in there. And as agile testing became a topic, that also a little added to the confusion, because that sort of stirred the pot a little. And again, Lisa and Janet did a fantastic job with that book, but it really stirred the pot. And for a few years, people on testing conferences, were really talking about, okay, what are we supposed to do? What do developers do? What do agile teams do? And so again, I wanted to clarify these roles a little.
Yeah, so let's maybe clarify that for our listeners a little bit as well. What do you define as testing? Because that's not even agreed upon, I think, by all people in the testing space.
Haha. And yes, and I so wish I had a super good answer to that. I do have a wish answer, like I wish testing was that, and I wish I could define this, but let's just explore the things that you may encounter when you speak about testing. So in certain types of organizations where I would say people are having a hard time adapting to certain practices, testing is the magic thing that only testers can do, no one else. So that will be one answer. The schoolbook answer is to basically execute software to find bugs. That's the schoolbook answer. I don't really like that because it's too narrow. So a better schoolbook answer is validating and verifying, because so now we're getting somewhere. We need to actually see whether the stuff that we're supposed to test is actually the stuff we need. It's not only whether it works correctly or does it actually have a place in this world. So I like that validation, seeing have we even included the right, let's call them, requirements. Does it meet the expectations? Does it delight? So that part I like. Another thing to put into testing that I like is detection and prevention. So again, there's like a temporal aspect in here. Testing is obviously the traditional word is detecting bugs, as I said, running software to uncover bugs, but we need a prevention aspect. So if you put those two together, it's a sort of a good definition. If it were up to me, if I could just wave my magic wand, I would say that I'd like testing to be about ensuring goodness.
Ensuring goodness,
yes.
That's nice actually,
yes.
because I mean, often testing is framed from a negative perspective. We want to prevent bugs, which is a negative thing.
Yes.
But making goodness is from a positive thing.
Yes,
and I think that nicely leads on to the next question already a little bit. What is developer testing? What is the difference between testing in a more traditional sense when a tester does it and testing when a developer does it? Is that the same thing, or are those really different things with different goals?
Again, if testing is about ensuring goodness or fitness, they obviously have the same goal, because that's a big goal. That being said, I just need to inject this because it's so funny. When I wrote the book, I've been at this for 4 years. True, there have been kids in between, but it took a while to write the book. In the printed version, I actually still didn't know what developer testing was. So just to give you some background here, the book actually started as a bunch of good techniques. Just this is like, if you do this and that, and if we combine this into one thing, it's probably going to be good. It's probably going to ensure goodness. After having had the book printed, I finally discovered what developer testing is. And developer testing is, so now I've got this catchy phrase, which I'm trying to repeat and sort of reuse. And It's the developer's intentional and systematic employment of testing tools and techniques with the purpose of achieving the highest possible correctness of the software that they write. And the keywords here are actually intentional and systematic, because that's as opposed to, first of all, if you've got the intention to use tools and techniques, you're obviously going to learn about tools and techniques. You're going to make some efforts to read up on them, to explore new tools and techniques. And if you do this systematically, you're going to tackle the hard cases. Because as I said in the beginning, people do, at least when I started writing the book, I used to see many unit tests which were, or tests for that matter, which were only targeting the things that were simple. And these simple things were kind of incomplete also, so that tests weren't really that good, and that wasn't systematic. So that's why I put systematic into this definition.
Yeah, can we really expect developers to test their own code? I don't know if this is a thing in Swedish or even in English, but in my native language, Dutch, we have a saying, the butcher approves the meat, which is, does it make sense if someone approves his own product? And it's not necessarily malice. It's not that developers are doing it intentionally. But if I overlook a certain scenario in programming, how can I still put that scenario I didn't even think of in a test? Is this really possible? Or is it a wise idea if someone else checks the meat or the source code?
Yes. Okay, so here we're actually on the topic of creator bias and stuff like that. And if you sort of make an argument for independent testing, this is kind of the argument you would be raising. As I will explore further, developer testing is a lot about preventing. It's about prevention. So in the ideal world, let's say we had an oracle that would be able to tell us exactly what fault scenarios that would appear in the product. So I would rather have that oracle sitting next to me, and me being the developer saying, okay, what are you going to test? What do I need to look for? And this is a little this effect that I'm looking for. So as a developer, you are biased. Yes, there are many good words for this, but at the same time, you need to verify your stuff somehow. So first of all, the option to not doing any developer testing at all is basically rerunning your program. That's just random, and it's haphazard, and it's tedious and boring. So that's one extreme. If you don't do any developer testing, which in this case includes unit testing, you need to rerun your program. Second thing is, as a developer, if you think about testing, just thinking about that this stuff needs to be verified somehow will affect the design. That's not controversial. You will follow certain principles when organizing your code. You will make it testable. So that's one thing. You will enable future testability, and I don't think there's any wrong in really doing your best. As a developer, you want to check and verify your code to the best of your ability. And yes, your ability will obviously be biased because it's sort of your child that you're examining, but I think that's the best option. And if you at that point in time happen to have your oracle or your testing buddy actually telling you, I will test for this, you can actually put all these checks in the code up front instead of having a tester doing them. So yes, there is bias, but the positive sides outweigh this anyway.
Definitely. And then this also relates to the different roles within a company of testers and developers. It used to be the case, I think, that there was a very clear role for a developer and a clear role for a tester. If testing is moving to developers, how does that influence the job of a tester? Do they do different things?
Well, I'd say that the thing that actually influences the job of the tester more is not really where the testing as such happens. It's more the delivery cadence. I think that's the thing that influences the testers' work. Obviously, if you were in the habit of delivering something, let's say on a quarterly basis or something, you especially as a traditional tester would work in a certain way. Now, if we need to deliver stuff weekly or bi-weekly or even more frequently, obviously whatever you did to ensure quality in these long releases has to change. So I think that is what's actually pushing the change in the tester role is actually the cadence, the delivery cadence.
Yeah, so the continuous delivery, having your tests run automatically and deploying every week is really different from when you were still burning your software on a CD and shipping it in a box.
Yes. So there's simply no way for an agile team to have a sustainable pace with usually testers are still outnumbered in teams, and there's no way to do your fundamental regression testing. So you need verification to be done or to happen as a result of developer work, because developer testing, I didn't really manage to squeeze it in up front here, but developer testing is a lot about freeing up testers' time, because my experience is that testers are in teams where developers are not very good at testing or don't do any testing at all. What's going to happen is that the tester will basically do what people call checking. They're just gonna verify, basically just double check, verify what developers do, and that's actually, I'd say it's a waste of time, and it's very boring it's really challenging, because the testers need to verify stuff over and over, iteration after iteration, manually, and this is something that doesn't leave any room for what I would call high value testing.
Yeah. And also for the developer, that's not a very comfortable situation, because if I make a mistake and the test tells me immediately, I'm in that piece of code and I can easily fix it. Whereas if 3 weeks later a tester shows up on my desk saying, hey, this is wrong, I have to remember what I was doing, what changes I made. So quick iteration, I think, also really supports the developer and not just the tester.
Right.
So I heard that some companies have started doing something they call the hybrid model, where the difference between testers and development is just gone. So they train the quality engineers on software engineering and they train the software engineers on testing, and everyone does coding and testing. Do you think that's a good idea?
Well, I haven't really seen this play out in practice. What usually, the model I've seen is the model of, let's call this the school book agile team or Scrum team, where everyone is a developer. So that title, Scrum removes that title altogether.
Yeah.
So everybody is doing product development, not development in the sense of writing code. Some days I actually miss the word programmer because it was quite clear what you were doing. So the way the teams I've seen, usually where in situations where testers were able to pick up on this, were able to adapt, and developers too for that matter, is that as a previous tester, you are still the one who knows most about quality, who knows most about testing techniques, exploratory testing, non-functional testing. This will still be your domain of expertise, but you will take more interests in the daily work of the team. You will no longer sort of wait for stuff to appear at your desk and you're supposed to test it. You as a tester in such a team, you need to be proactive, and that's actually how I would summarize agile testing.
Yeah, so it's more about the process and the team. You think that hybrid model will impact than really the job or the work you do every day, and be more engaged and.
Yes, I think if you phrase it like that, that is the outcome you're looking for, and by sort of cross-training people, you're hoping for that effect, and in essence, that's good. Again, if developer testing is actually facilitating this kind of hybrid thing, because it actually really brings in testing techniques and shows you how they are used in your daily development work. So from that point of view, developer testing is really, really a cornerstone for this. And again, returning to this shorter delivering cadences, as a tester, if you're not technologically savvy, or at least you don't need to, you were never supposed to be a super developer as a tester, but you need to understand about the technology. You need to know the technology stack, because different stacks will have different characteristics. They will be prone to different kinds of defects, and especially since the stacks are getting more and more complicated, there are more moving parts, there's more boilerplate, it's kind of hard to be able to spot root causes of the defects unless you know where to dig. So I think this becomes more or less inevitable.
So I think we can agree that writing a unit test is programming, because that's writing source code.
Yes.
So are there forms of testing that are not programming? Are there extra skills that testers have that aren't programming?
As for skills, I'd like to emphasize more the mindset.
Which can be a skill, I think, having a certain mindset.
Wow, that's the deep one. I need to sleep on this. It
might be slightly out of scope for this podcast.
Yes. I will really sleep on this one. So again, I like to speak in terms of roles, and if you are in the role of the tester, you will obviously do different things. You will work more proactively with you basically you will be the one asking the questions. At least to me, the tester role is the inquisitive role. In every situation, you're supposed to ask what could possibly happen here, what could go wrong, and there are so many ways stuff can go wrong. Again, will the users like this? Will the users like the product? Have we explored all the variations of the I don't like the word requirements, but requirements. Will there be any security issues? Will there be any performance issues? And these are questions you need to be asking constantly. So that's the important thing here.
Yeah, so maybe I can summarize that as the tester ultimately has the customer as a central thing in their job. They think, will the customer like this? Will it work? Will it not be buggy? Where a developer ultimately has a product central. They are building the product. Is that a good summary of what you said?
Well, actually, in a perfect world, I would actually hope that both work towards the same goal. However, how this plays out in practice is that provided that the developers do the fundamentals like developer testing, they will be focused on actually implementing the product and implementing the code to test the product. Whereas in this scenario, as a tester, you will have time to not just double check what the developers are doing, and you will have time to ask all these questions.
Yeah, so in your book you describe this, I think, really well, because you describe clearly two different objectives for testing. One objective you call the critique objective, which is basically, and the developer says it works on my machine, and then the tester or the person that's in the role of testing is trying to critique the piece of software. Where you also have the support objective of testing, where the testing is supposed to make programming easier, to make turnover quicker or make it less painful. So how are those two test objectives different? And do you typically have both within a company? Or are some companies really the test critique path and are others really the test support path? Can you elaborate on that?
Oh, yes, I'd love to. So first of all, this is sort of borrowed from the agile testing quadrants, of course, Brian Merrick, and popularized by Lisa and Janet, of course. But this also includes my favorite straw man, which is traditional testing. So the actual traditional is my favorite straw man. Traditional testing is not able to fight back if you sort of take some stabs at it. So what I wanted to say with that, these paragraphs here, is actually, first of all, I wanted to highlight this old, creepy adversarial parts of testing, this where you sort of are suspicious. You want to basically, well, I've met some testers, let's just say it like that. I met some testers who were very, very happy when the developers failed. So and that's actually the label they put on them. The developers have failed. So there's of course there must be joy in discovering defects, because you need to be motivated. I mean, you need to be able to leave your bed and go to work and do stuff that you're happy about, and finding bugs is something that makes you happy. But I think there's a difference between finding a defect as in contributing to the quality of a product versus finding a defect just to see that somebody has failed. So
yeah, it's also really the difference between, of course, the developer and the product. If I find a bug and I want to make the product better, that's really different from saying you as a person have put in that line of source code that is wrong. That is a different mindset.
That's horrible, and unfortunately, it still happens. I wish it hadn't, but it's still. But I think it's going away. There's a good trend here. But anyway, so this critiquing, there are two dimensions of critiquing and supporting. Again, if we just look at the Agile Quadrants model, which has tests, actually the newer Agile testing quadrants nowadays call this guide development. It's not support, but it's called guide development. But and this is what developer testing actually is. You need practices, you need techniques that will help your development, which, I mean, the obvious case is, of course, unit testing, but basically any kind of testing or checking that can be automated by developers is guiding your development and is supporting. But there's another dimension too, and I think we've touched on this, is you as a tester, your objective is not really to find flaws. Your objective is to contribute to a good product. So whatever you do this proactively, and you do this in a supportive manner. So that's testing to support. Whether testing to critique, in the Agile quadrants, it's actually just looking at the product from the outside. It's basically evaluating it. So it's critiquing but not criticizing. So that in the Agile quadrants, that's what it is. At least I hope it is. However, what I wanted to bring into that section, particular sections of the book, is that this critique mindset, it just may become too much, and it's again this you're just speaking in terms of risk. You speak of distrust. You're actually building on the false building metaphor for software construction, when you expect a good blueprint and you expect that blueprint to be implemented, and you see yourself as some kind of building construction inspector. You want to examine the shafts, the wiring, and hopefully you want to find something wrong. You want to find these cracks in the concrete or something. And that's my favorite straw man, actually.
So suppose you're in a situation, and some of our listeners might be in a situation where testing is mainly critiquing. How do you move your organization towards more the support form of testing, which I think might be a more fun environment to work in, a more constructive environment to work in? Is this possible? Have you seen in your work as a consultant organizations make that shift, and if so, how?
Okay, so I wish I had very good news here. I wish I had a simple formula and silver bullet, but basically what this is, this touches on the big topic of agile transformations. It touches on the topic of change management.
It's bigger than testing.
Yes, it's bigger. It's a big mindset shift, and you would use basically all your skills and tricks in these two areas to change a team's work. One thing that usually works actually, or it's sort of stuff under, or let's say things will either bend or break. Again, if you shorten your cadences, you need to do stuff differently. And if you adopt truly agile development, where you're not just sort of doing iterative incremental development, you're not just paying lip service to it, but you do actually have shippable and preferably ship software often, this will force you into certain working habits. There's no way you can sustain certain
old
ways.
way of working.
Yes,
yeah.
there's no way. But the caveat is that you can't sort of play, I'm going to use Scrum as an example, you can't play Scrum here saying that, okay, we've got this, we're delivering in 6 months, but we do have our 2-week sprints, because I have not seen that work. You can't force this change by playing Scrum, so to say, or any other agile methodology. So that will drive obviously will drive this change. Another thing is actually rotations within the teams. I mean, teams are on paper static, but they are dynamics. Especially as a consultant, I enter and exit teams, and if the mix of people changes, or formal and informal leadership changes, you have your opportunities.
Yeah,
but something needs to. Just talking about it, advocating it, I've never seen that strategy work.
So you have to really be able or be willing to make changes within your team, within your organization, for that change to work.
Yes. Or either you need to be pressed into this again, or you need to sort of swap out enough people to make that change happen.
So we've been talking a lot about Agile and Scrum and testing, but in your book you make another connection between software craftsmanship and testing. So I love software craftsmanship, and the way I see software craftsmanship is that it is about emphasizing skills, coding skills of developers. You have to take yourself serious, your own skills serious, and with that you take your source code serious. Is that, do you agree on the definition of software craftsmanship?
Yes, I think the key word is skills here.
Yes, I agree.
It's skills. So I just happen to have the Craftsmanship Manifesto with me here.
You came prepared.
Yes, I came prepared. I don't know how I knew. And again, if I read it, it says not only working software, but also well-crafted software, not only responding to change, but also steadily adding value, not only individuals and interactions, but also a community of professionals, not only customer collaboration, but also productive partnerships. Actually, from my point of view, I usually make the connection between points 1 and 3, which is well-crafted software and community of professionals. So I think if you just say what is software craftsmanship to you, these are the 2 points that will come up. And with this, it comes certain practices. I would mention there are several books on writing good code. Robert Martin's book, Clean Code, is obviously the most famous one, but there are other very good books.
Do you have a few suggestions that you can share?
I would so love to, although I don't really remember at this point.
That's okay. We can add them to the notes if you have.
I've got them on my review site. Actually, they slipped my mind. There's actually one very good. It just slipped my mind. Sorry.
We'll fix it later.
Yeah.
Searching for a new job is stressful and scary. Then you go through the interview process only to find the salary offer or company culture doesn't match what you're looking for. Hired.com is the world's most intelligent talent matching platform for engineering. We make your job search faster and stress-free. After completing the application, top employers apply to hire you. You receive personalized interview requests and upfront salary information. Your dedicated advocate will assist you, providing career coaching to help you with potential employers. Hired.com hides your profile from current and past employers to respect your privacy. The best part? It's always free. Today's SE Radio listeners can earn a $2,000 hiring bonus by signing up at hired.com/SE Radio. Find your next chapter at hired.com/SE Radio.
So, how is software craftsmanship related to testing or to developer testing?
Okay, so developer testing will thrive if there's an underlying technical excellence, because what I would put into software craftsmanship is, again, just clean code is one thing, refactoring is another big thing that you need to do, and there are certain principles. At least it's just me putting them in the bag of software craftsmanship. It's a little like command query separation, following the law of the meter and stuff like that. And all of this is sort of pursuing this actively, learning about this stuff and making your code align with this stuff is software craftsmanship to me, and reaching out to other people who obviously want the same. At least that's software craftsmanship to me. And of course, it's easier if you've got this objective. It's not a very big step to take to say, okay, we have well-crafted code. Now we need to see that our well-crafted code actually works and will keep working iteration after iteration. So in that sense, the step is small.
Yes.
However, there's a but here, and I think you can probably, now I haven't spent too much time thinking about this, but I think you can have well-crafted code which is not very testable. Which is, or I need to construct some example. I haven't really thought about this, but I think it's not the one-to-one mapping, actually.
That is interesting. We need to
yes,
talk about that a bit
yes,
more.
I can't make the promise, actually. Maybe this will be my homework. I don't know. So maybe I'll change my mind.
So you just mentioned testable code, and this is also in your book a topic that comes up. So what is testable? What makes code testable?
Love that question, actually. And this is something, again, speaking of recurring learning curves and patterns, as a consultant working with software quality, this is what I hear a lot. Our code is not testable. And one sub-objective of my book is to actually teach some nomenclature, testing nomenclature, where testable is actually one of the words you need to know. And if you just Google testable, you will find, and I don't think people do that often enough, you will find that testable is code that's observable and controllable. So, and I love that. That's the schoolbook definition. And it's actually a very powerful definition, I would say. In the book, I chose to add code that's small, and smallness as a property.
So can we zoom in on those two words a bit more, because I'm not sure everyone understands what exactly they mean. I don't really understand. What does observable really mean? What does controllable mean?
Oh, yes.
Can you explain a bit more?
Yes. So these are properties that apply at all levels. For example, if you complain about your unit tests, a very common pattern of failure with unit tests is, for example, that your unit test does things that a unit test is not supposed to do. It reads something from a file system, it expects something to happen on the network, stuff like that. These are things you don't always control. Your file system may be structured differently, your test server may not be responding, stuff like that. And as soon as you lose that, your code becomes untestable.
Yes.
And this scales. That's the beauty of it. If you scale, that's on unit test level. And again, now I got carried away here, but I'm just gonna slow down. It scales because if you look at systems, for example, an entire system may be untestable because of external dependencies that you simply can't control. A practical example of this, where I really encountered this, is I used to work with testing logics for buying and selling stocks. And the only sort of realistic testing environment available was actually a public environment where many different actors were able to do their transactions.
So that was like live data or something?
Yes, live data. So there was no way, for example, and there were reasons, if time permits we can sort of dive into the reasons why we didn't stop this environment out, but there were reasons for really keeping this environment. But basically, if we put an order, we wanted to buy or sell something, someone else snatched that order, and that happened on the system level. So here we had, obviously, we had observability because we were able to query the system. We could see that our order is no longer there, but we didn't control it.
You didn't have control.
Yeah. And this is, I mean, the profound thing is here that it scales across all layers, and it starts at the unit level and scales up to system level. So controllability is obviously being able to set things in a certain state. An enemy of controllability is often the database. People seldom take the time and the painful process of actually setting up their database and setting up whatever layer they need to populate a database with certain test data. That's the poster child for controllability.
Yeah.
Yes.
So you mentioned the outside world a lot, like live data and a database, but are there also properties of the source code itself that make code untestable?
Yes, there are a few, but again, the thing is that they are actually falling into these are the big groups. So if you just keep these in mind, you're probably going to be fine. But if you break this down on like a more manageable level, obviously things that will affect your both observability and controllability are indirect input and output.
Yeah.
And simply what these things are is, because again, this is so common, how to deal with indirect input and output. And I'd say first step one is to understand what that is, to be sort of name the devil first. So what is indirect? So output is direct, input and output are direct if they're observable through the public interface. You send something to a method, routine, function, call it whatever you like, you get a result back. So that's obviously direct input, and what you get back is direct output. If all your code were structured like this, you wouldn't call it untestable.
Yes.
Because everything, you can see everything. However, as soon as your routine becomes kind of a black box and it starts creating, it's as simple as actually as creating other, let's call them objects here, or entities, or so. It starts creating things, it starts reading something again from a database. Obviously that's indirect input. It starts sending stuff. It could be as simple as printing. I mean, your Hello World program has indirect output actually. So your Hello World program is actually it's actually harder to test.
But these are scenarios that all developers encounter.
Yes.
We do have to print. We do have
Yes.
to read from the database. What do we do, Alexander? Help us. How do we test that type of things?
Again, first, the key success factor is to name it. And if you can name it, you will know that this is where your different kinds of test doubles enter the scene. And basically there's a mapping. It's more or less one-to-one mapping between type of test double and your problems of indirect and direct input. So stubs, a stub is the test double, the sole purpose of which is to provide indirect input. I mean, that is the purpose of a stub. A mock object, the purpose of a mock object is to verify indirect output. So it's actually, if we can name stuff, we have the test doubles. That's a solved problem.
Okay, that makes sense. Thank you. So your book doesn't only cover unit testing. You go a lot deeper. You talk about more rich techniques that are available to developers. And one of those techniques that you mention is the idea of design by contract, which is a relatively old idea already, as advocated, for example, by Bertrand Meyer in Eiffel. So for those listeners not familiar with that concept, what is programming by contract?
Programming by contract is... okay, so you, first of all, the design by contract and programming by contract thing. When I did the research for the book, I actually wanted to call it design by contract. That's the name it's known under. However, that particular thing is trademarked, so I needed to put that's why I had to put programming by contract. And basically, what programming or design by contract is, it's about formalizing responsibilities. You're saying that a class, says the definition, and its collaborators, they have a relationship. There are obligations and there are benefits. So you formalize a relationship between two program elements. I like that word. Program element is a fantastic word. So it's about formalizing the relationship.
And then program elements can be methods or classes or APIs. It's more about. I think it's easier. The easiest case is really the method, the API level. There are variations, but that's the easiest case. So why isn't design by contract really mainstream? It's an old idea, and it does seem like a very good idea. Make it very clear, document what the responsibilities are, yet it doesn't really happen in practice. Why do you reckon that is?
I wish I knew. I do have some theories.
I want to hear your theories.
So one theory is that probably it touches a little, it may feel a little too much like formal methods. It feels very formal. Okay. It feels documenty, if you get what I mean.
Yeah, it doesn't feel like programming.
Yeah, you need to stop and think. That's bad. You can't bang on your keyboard. You need to stop and think. So that's one thing, and the other thing is that the constructs supporting it, they're not really primary citizens in the languages, in the popular languages.
So you mean things like preconditions, postconditions?
Yes, exactly. So, and I mean, in Eiffel, where these things are actually built into the language, they read very well, they're very explicit. Unfortunately, Eiffel, if you look at the common, these indexes for programming, language popularity, TIOBE index and the PYPL indexes, I think Eiffel is somewhere below 0.183%.
So if we want to do design by contract in more traditional or more mainstream languages, Java, C#, do you need libraries or frameworks for that?
Every language has well, I shouldn't be careful about saying every, but the striking majority of languages has the assert keyword, which is like the standard thing for enforcing pre and post conditions. There are libraries for contracts for both Java and the .NET environments, and obviously other environments as well. The way I think about programming by contract in the context of developer testing is that I don't really think, to me the essence is actually the mindset of that there is a formalized responsibility between two program elements or two things, and that formalizing this responsibility will help you to answer the question, how many tests do I need to write?
Okay, so it's not about putting the putting the formal responsibility in the source code per se. It's more about thinking about the responsibilities, and then you have them in your mind, and they're part of the shared understanding of the source code, which is then supported by the tool.
Yes, because there are different ways to actually enforce contracts. Again, in Eiffel, the traditional way is runtime verification. You can partly enforce contracts by static analysis. Actually, you can do that. And I'd argue that unit testing is actually, again, a way of enforcing contracts, because it's really, again, the contract is an abstract construct. So there are different levels, but to me, at least to me, it's proven most valuable to just have this as an idea to generate tests, because there are, again, returning to this learning curve, a very common question is, how many tests do I need to write? Like
when
if
am I done testing?
Yes, exactly. Like if it's quantifiable.
Yeah.
But this is one angle to it. There are other angles to it, but this is one thing that will help you determine the number of tests to write.
So is this worth it for all type of projects, or does your source code need specific characteristics for it to be worth it to invest in design by contracts? Or
again, depending on what you would actually put in the definition of investing into programming by contract. I mean, as soon as you've got one thing calling the other, you have a contract.
Yeah,
so,
it's just a matter of, is this an implicit or an explicit contract?
Yes, and putting invariants around that thing or may not be worth it, especially if you're in an environment that doesn't do this traditionally. However, stopping and thinking about this is always worth it. I mean, you need to be explicit about your interaction.
Yeah, so again, in lots of the points that we've been talking about, it is about writing down, or at least understanding what the expectations of the source code are. I think we can summarize it like that.
Yes.
So something else you talk about in your book, which is related, I think, is specification-based testing. So this is about writing down the expectations even more formally, right? What do you consider to be specification-based testing?
So the word I'm using is specification-based testing techniques, and it's very undramatic. This is, again, a very Googleable word, which you will find on your basic tester exam. What's sort of important about specification-based testing is that this is one of these things that didn't make it to the developer books and blogs.
Yeah, to the mainstream testing world.
Yes, it's been confined to the testing world. It's never been, or at least in my mind, it's never been made popular enough among developers.
Yeah, I agree. I go to lots of conferences, and I don't think I've seen lots of talks about specification-based testing or design by contract in recent times.
But the thing is, there is a good reason for that too, because it's extremely unsexy, actually. I mean, the only thing is specification-based test techniques, and actually I don't even call them by that name, I just call them fundamental testing techniques. It's the testing 101 techniques for testers, and they're called specification-based techniques because they can be derived from the specification. If you have your user story, or you have a formal document or a wish list or whatever, you can study this and you can derive test ideas.
So how do you do that? Suppose I have a user story right in front of me and I want to derive tests from it. What do I do? I shake the paper until the tests come out. What do I do practically?
The thing is, let me just explain the things I put into specification.
Please do.
Yes. So there's, again, as I said, very unsexy. It's equivalence partitioning, it's a boundary value analysis, it's state transition testing, it's basically different types of truth tables. So
can you give an example of one of those?
Sure. Normally, I'm going to give you just a school book example. Let's say you've got whatever numerical input, the classical thing, people under a certain age may not engage in certain transactions or whatever, and you have an age check. So a boundary value analysis or let's start with equivalence partitioning. Obviously, in that particular case, you may have two partitions of data, because if you enter your age, you're obviously going to be in the valid part of this interval, and you'll obviously be in the invalid part. You will be younger than, let's say, 18 or 20. So that could be two partitions.
And
there could be more. There could be more where you actually send in complete garbage into this. You could treat this as a separate partition. The important thing is not really how you slice these partitions. The important thing is that you're aware of their existence. Now, in between these partitions, this is usually where bugs lurk. I mean, it's so easy to, if you have your age check, it's so easy to omit a character or something, and you won't be able to hit the interval correctly. So
it's like smaller than or smaller or equal than
exactly.
are the type of things you could miss.
That's what I was envisioning. And so this is where boundary value analysis comes in, is that you know your partitions, and you know that I need to pay more attention to the boundaries, so you will obviously test more at the boundaries. Related to this is obviously different heuristics for certain values that may or may not be around the boundaries of different partitions, but you may want to examine them more closely anyway. And these are things like empty arrays, collections, stuff that's empty. Yes, I was more thinking about nulls, like really edge cases, nulls, empty collection,
numbers,
empty strings, yes, nans, not a number, kind of stuff, and this, and heuristics. Typical heuristics for testing is 1, 0, many, which is applicable again for at the unit test level. So this is boundary value analysis and equivalence partitioning. State transition testing basically is about modeling your certain types of software will really be best modeled as state machines. And if you sort of go through the hassle of somehow modeling this, you can either do this graphically, or either do this formally, or just write it down on a whiteboard, but really visualize the states and the transitions and derive test cases from that. And obviously you've got the table, different decision table kind of stuff. Again, is to just visualize all the inputs and outputs and outcomes. And from these techniques, if you apply them consistently, this is where your magic, if you shake your little index card, or at least if you shake something which you've produced using these techniques, your test cases will fall out.
Yeah, so all of these techniques, I think we can catch under the umbrella of helping you to come up with new test cases.
Yes.
And this relates, I think, to what you said in the beginning of the podcast, that many books about testing are about how to execute tests, how to run tests, but not about how do I know what I'm going to test. And these are all ways to help you think of what are the responsibilities of my model, what are the states that my thing can be in, to help you think about new test cases. Is that correct?
I would phrase it slightly differently.
You are the expert. Go ahead.
I would say that, again, this is so super basic, is that you don't even speak of this anymore. As you said before, you will not see these topics on a testing conference, because that's like below 101. It's below 101. However, the crux is that it's below 101 for people who have a testing training. It's not below 101 for developers.
Yeah,
and
also
by bringing these things to developers, I mean, these are things, if you are a super novice testers, these are things you will try first. However, these things are also manual, they're repeatable, they don't really require any creativity because they are so well formalized. You know, of course, you can actually argue over your different partitions. It's not always easy to partition stuff, for example. It's not obvious how to partition, but most of the time it kind of is. So as a developer, if you're just aware of all this, you know what to put in your developer test, and that partly also helps you to mitigate this creator bias, because at least you have certain ground rules. I will use these techniques, and I will base my test cases on these techniques, and then I've got all of this covered. Then comes somebody who's an expert in testing and trusts you to have put all of this, verified all of this. That person may do some sampling, but that person will be able to do something.
Yeah, and also it gives you a shared vocabulary, because now a tester can ask me as a developer, what partitions did you consider? Or they can say, did you think of the state machine? Did you write it down? Or how many states do you have? And that makes it easier,
so
I can
correct.
imagine, for the tester to communicate with you.
Yes, and thank you for bringing this up, because that's also so important that's actually, again, I've got all these sub-goals with my book, and I dedicated an entire chapter just to the vocabulary to facilitate communication and collaboration. So thanks for bringing this up.
So I want to talk about two more controversial topics, if you're still with me.
Yes.
One is test coverage.
All right.
Should we care about test coverage? Is this something you should care about as a developer? Is this something you should care about as a tester? Or is this an entire non-issue and you should just test until you feel you've tested your system well enough? Or is there a number we should go for?
Okay, there's a number you should go for. Okay, so on the best projects, I'm going to start with the anecdote. On the best projects where we've actually employed developer testing, test coverage was never an issue, because if you write your unit tests, or if you do that test-driven development and you write your integration tests, your coverage will be above 90% automatically. So when doing developer testing, coverage is actually non-issue. However, the issue with coverage is of course that it doesn't really tell you anything about correctness. It just tells you that one piece of code has executed another piece of code. So I think these are the lines along which I'm usually reasoning. So it tells you, for example, coverage tells you that your code is testable. You are able to write one routine that is able to test another routine. That's a good thing. So obviously your coverage shouldn't be dropping. Personally, I like high coverage because of that, because it tells you code is testable. Somebody has made an effort to call your code, to exercise your code. However, it will not tell you about the quality of your testing.
Yeah, so it says something about internal quality, but not necessarily about external quality.
Yes, these are good labels to put on this. Yes, so aiming for a number, again, I think it should be a rising trend, but just if you aim for a number, you need to know why you're aiming for this number. Just saying we need 50% or something is not really, in my mind, solving any problems.
Okay, second controversial topic.
Okay.
Test first or test last? Should you write the unit test before you program, or first programming and then the test, or it doesn't matter, or it can be a mix? What's your take on this?
Okay, so first of all, I've been not slavishly, but I've been following this debate. It's been going on forever, and to be honest, I think I've stopped following it a while ago, but I'm sort of resuming it on different conferences, and so I'm slightly familiar with it. What's one thing that in this debate that has happened is actually, I think we lost the notion of unit testing. It's either you do TDD or you don't do TDD. And if you do TDD, you're good. If you don't do TDD, you're bad. We've sort of lost a little okay, I'm not doing TDD. I'm a super duper expert in unit testing. Am I okay? So we've lost that at least to me, that dimension has been lost. So the debate is slightly one-sided. It's do TDD, not do TDD. My take on this is that testability is a function of controllability, observability, and smallness. And it's not a function of time and precedence. So in a way, to novice developers, test-driven development sort of carries the promise. If you do this first, then something magic will happen. No, I'm being a little mean here, but so that's from the testability point of view. So there's nothing magic about test-driven development. That being said, writing your tests first will obviously ensure that you reach these goals. I mean, you need to, if you start with a test, you will obviously reach controllability and observability by definition, because otherwise there's no way you will be able to write code that will make that test pass. So it's a fantastic way of reaching these properties, and smallness also because actually TDD tells you not to it will prohibit you from adding extra code and stuff like that. So you will reach all the properties of testability doing TDD. However, it's just that if you know these properties, there are other ways of reaching them.
So I think what you're saying is that test first is a good strategy if you're just starting with this, if you're starting with writing tests, but after a while you get used to it and then it doesn't really matter anymore when.
Well, there's another dimension to this actually, and it is, and I think that's overall the biggest challenge with doing TDD is that it requires you to be able to first visualize what you're actually going to do and how it requires to visualize how you're going to test it. Often you work with a stack or technology that you're not really familiar with. You're working in a system you're not really familiar with. It's got all sorts of side effects and quirks going on, and sometimes you really need to just prototype your way through different layers, and in these situations TDD is really, really unhelpful. So that's the other dimension.
So it has to do with controllable. It has to do with how much do you know about the system, how much can you control about the system.
Knowledge about the system, the domain, and the problem actually. Sometimes we really just need to go crazy and try things out. So what I do in these cases is that there's no testing whatsoever. There's no unit tests at all. However, as soon as, and I think I do this even subconsciously, as soon as I've got sort of a clear idea of, okay, it's probably gonna go in that direction, I think I'm actually reverting to TDD. Then there's of course different types of TDD, and there's different rigidness about TDD. The TDD I present in my book is not as rigid as
the classical version.
Yes, so I'd like to put the label pragmatic on my TDD. Obviously, the tests are written first, but
not religiously. No,
they're written first. In the book, they're written first. It's just that, for example, in the classic book on TDD, Kent Beck uses the refactoring stage to really remove duplication, whereas I use my refactoring to really get rid of ugly code. Sometimes I get rid of duplication, sometimes not, sometimes I get rid of something else, and sometimes I end up in situations where I really need to, I have sort of done my refactoring, but I'm looking ahead and okay, I need to refactor again. So I am cheating a little, maybe. I don't know, but
I like the label pragmatic. It's a good, basically TDD test first is a good idea, but it isn't always practical. So being somewhat pragmatic about it, I think, is a good idea. So that's more or less all of the time we have. Of course, we will link to your book if people want to know more. Are there other resources where people can read from you?
Yes, there are. Actually, there's the book companion site, which is developertesting.rocks. developertesting.com was taken, so I registered .rocks. Now that's an ongoing project, so stuff is being added as I go. I don't have an infinite amount of time, but I'm trying to put a little tidbit here and there as I have time. So I think that's where stuff is going to happen. Yes.
Okay, so we will put that in the show notes according, along with a link to your book. Thanks for being on the show.
Thank you for having me.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.